Hey guys, Dr. Darbro. The title of this video is Combining Means, and my terminology is I say problem solving with sample means. This is not a topic you're going to find in a textbook. Well, as I say that, you may find problems embedded in exercises at the end of a chapter, but this is just a little something extra that I like to do in my classes when I teach statistics on campus. The reason being is I found so many people that didn't know how to do this, so many students that didn't know how to combine sample means correctly. So that was a motivation. So let's get started. First of all, when you encounter problems like this, I want you to think of sums. And I'm going to develop the concept behind thinking of sums. And I'll do that by beginning with a very simple formula, the simple formula that we've hopefully seen before, and that is to find the sample mean. We take the sum of the scores divided by the sample size. So again, let me bring up my pen here. This over here, x bar, for the rest of this class will stand for the sample mean. This notation right here, sigma x, stands for the sum of our scores. And obviously the n right here stands for our sample size. So again, to find the mean, we take the sum of the scores divided by the number of scores that we have. Now, if we'll multiply both sides by n, on the left-hand side we get, bring my pen again, on the left-hand side, we just get that the sample mean is x bar times n. And then on the right-hand side, we get the sum of scores divided by n times n. Now, you probably know what's coming next. What we're going to do next is, since n cannot be 0, we can multiply by n on both sides. And these n's on the right-hand side will cancel, giving us step number 3. So step number 3 says, in a nutshell, that we can find the sum of our scores always and forever by taking the sample size times the value of the sample mean. So guys, keep in mind that the notation sigma x in statistics is nothing more than the sum of our scores. And keep in mind that we can always find the sum of our scores by taking the sample mean times the sample size. Alright guys, pretty cool stuff. Alright, let's go in and take a look at 3 types of problems. And I'm going to shake things up a little bit here. Instead of using the graphing calculator, I want to show you the feature on R where it works kind of as a graphing calculator to do basic operations of arithmetic. So I want to give you the problems, and then I'll switch over to R and show you how do we work these problems, okay? Okay guys, problem number 1. A high school teacher's, okay, that's going to drive me insane. So a high school teacher, let's get rid of that S right there. So a high school teacher is currently teaching 2 algebra classes. Her 9 a.m. class has 28 students. Her 3 p.m. class has 42 students. Each class recently took an examination. The average score for the 9 a.m. class was 82. The average score for the 3 p.m. class was 78. The teacher would like to calculate the average score for all of her students, including those in the 9 a.m. and the 3 p.m. class. Now, the worst thing you can do here, because it's just wrong, is to take the 78 and take the 82, add those 2 things together and get 160, and say, well, the combined mean for the class is going to be 80. This is a simple problem, right? Well, yeah, it's simple because we did it wrong. Guys, the mean in this problem won't be 80 because we can't take the 78 and the 82 and divide them, or add them together and divide by 2, because we have more students in the 3 p.m. class than we do the 9 a.m. class. This phenomena gets into what we call a weighted mean. So you're going to throw out what you think would work, and what's going to be the solution? Well, you're going to let me teach you. And the solution will be we're going to work with sums. Next problem. A basketball player has played 23 games and is averaging 9 points per game. How many points will he need to score in his next game to raise his average by 1 point per game? This again falls under the realm of problem solving with means, because again, averaging 9 points per game. Instead of doing something goofy, what are we going to do here? Well, our solution is going to be to work with sums. Problem number 3 is something you guys will definitely encounter pretty soon. College student wants to calculate her her GPA for a given semester. She earned the following grades. Got an A in statistics. You knew I had to do that. Got a C in yoga. I don't know how you get a C in yoga, but didn't do so well in chemistry and got a D. But you'll notice each of these courses has different credit hours. Biology was 4, statistics was 3, yoga was 1, and chemistry was 5. So how do we handle this type of a situation? Same way, we work with sums. Alright gang, what I want to do here, again, it would be probably easiest to work these problems with the graphing calculator because really it requires us being able to multiply, add, and divide. But what I want to do is I want to get out of this and I want to go into R, which I already have up. Notice what I've done here is I've already stated the problem, so I don't have to go back and forth to the PowerPoint. And notice also that I started each one of these lines with the hashtag to give Twitter a little bit of notice, and kind of summarized each problem. Solution for each of these. Work with sums. You guys remember again, we find sums by taking the mean times the sample size. So for the first problem, what I would need to do is I would need to take the mean, which is 82, multiply it by the number of students, which is 28. I want to add 78 times 42 for the 3 p.m. class. So what I did here is I took the mean for the first class times the number of students for the first class, the mean for the second class times the number of students for the second class. And you can see that R works just like your graphing calculator in that not only does it do statistics, it also does basic arithmetic operations. So guys, I know now that the sum of the scores for both classes combined is going to be 5,572. Well, it would make sense that we take the sum of the scores for all of the students and we want to divide by the total number of students that we have. So I take 5,572, which is the sum of the scores for all the students, divided by the number of students that I have, and the average would be 79.6. Now, notice if we range from the lowest average for the 3 p.m. class, and let me start with hashtag here, and we go to 78, and we go to 79, and we go to 80, and we go to 81, and we go to 82. Notice that 80 is in the middle of 78 and 82. If we had the same sample size for 9 a.m. and the 3 p.m. class, then we could just add the 82 and the 78 and get the middle of 80. But this isn't the case here. The 3 p.m. class, which had an average of 78, contains more weight because there's more students that contributed to the 78 than contributed to the 82. So what we're going to expect is we're going to expect the mean to be drawn toward the 78 because the 78 has more weight because there's more students to the 42. So before I even work the problem, realizing that 80 is right in the middle of 78 and 82, I knew that the mean was going to be below 80, drawn toward the 78, because more students contributed to this. So guys, again, what's this called? This is called weighted means, because the mean with the highest sample size in is going to get the most weight. So guys, the answer to problem number 1 would be 79.6. All right, let's work problem number 2. Problem number 2. The player has played 23 games and is averaging 9 points per game. Now, I don't know what the scores have been, but I know that this basketball player had to have scored 207 points. Because if I take 207 divided by 9 games, that's the only way that I can get, 207 divided by 23 games. Let me do that again. 207 divided by 23, then I get 9 points per game. 207 is the only number, it's the only sum of scores that when I divide by the number of games that the person played, that I get 9 points per game. I don't know the scores, but I know they had to add up to 207. And how did I find that? By working with sums. Working with taking the mean, taking n times the average. Now, let's think about what has to happen for this basketball player to raise their average by 1 point per game. Well, they wouldn't have played 23 games, they would have played 24. And they wouldn't be averaging 9 points per game, they would be averaging 10 points per game. So if I find the sum that creates the goal, subtract the sum that they currently have, then clearly what does that difference have to represent? Well, it has to represent the number of points that that basketball player needs to score in the next game to achieve their goal. So this is a little bit different twist on combining means, in that we look at the sum of scores that we need to achieve our goal, and in this it's to raise the average by 1 point in the next game. We subtract the current number of points we have. Well, the difference in those two sums has to be the extra point value that we need in this case to achieve the goal. All right, problem number 3. Problem number 3 is a little different because we're working with something called quality points. And quality points are nothing more than the grade times the credit hours. Now, this is very closely mirrors working with sums, with averages and sample sizes for obvious reasons. So what I would want to do first of all for the stats, again assuming that, and again we'll assume that A is equal to 4 points, B is equal to 3 points, C is equal to 2 points, D is equal to 1 point, and an F obviously is equal to 0 points. And I think that's pretty consistent. That's not much of a stretch of the imagination to work with that scale. So guys, what we want to get is we will get the total points. So in the stats, we have a 3 times 4. In the biology, we would take a 4 times 3. For the yoga, I still don't know how you can get a C in yoga, but maybe they didn't go to class. English, we would have 3 times 3. And chemistry, we would have 5 times 1. Now, that's going to give us our total quality points. And what did I do wrong? Non-numeric binary. Oh, yeah, see what I did? Okay, you know what? I'm actually glad that happened, because I didn't do that on purpose, by the way, but I'm glad it happened. What I can do is, R has a copy paste. So if I come in and do copy and bring this down and do paste, what it'll allow me to do is to go in and edit, and of course we know C has a quality point of 2, and we can actually see that we have 40 quality points. What we now need to do is take the total quality points and divide by the number of credit hours that we took. Well, not we took, but this student took, okay? So we have 3 from statistics, 4 from biology, 1 from yoga, 3 from English, and 5 from chemistry. So guys, this student ended up with a 2.5 GPA for the semester. And again, calculating GPAs for semesters and calculating how many points a player needs to raise a batting average, or combining averages from 2 classes as we did in problem 1. This all falls under the heading of working with weighted means. Guys, that's all I got. Have a good one.